All right, guys. So the video I uploaded is not working, so I'm going to send you a new video. So basically, we're learning about sound today, and you need to understand what sound is and how the vibrations affect your ears, how you hear things, and also how sound travels. All right. So everybody has an eardrum inside their ear, and you have the ability to hear noises. Now, some noises are going to be louder than others, and that's the way that the sound waves are traveling. So, the faster the sound wave travels, the faster it hits your ear. The slower the sound wave travels, the longer it'll take to hit your ears. So, look at this. One of the animals that completely rely on sound waves are dolphins, and another animal is a bat. They use echolocation to figure out where their other animals are in the ocean or in the air or wherever, so they don't fly into things. So when those sound waves are bouncing and they hit a tree, they bounce back to the bat, and that tells the bat there's something there. I don't need to fly that way. All right, so let's look at the page about the ears. So this is basically about how your ear works. And I'm just going to give you a summarization of what it talks about. So, fun fact, the smallest bones in your body are found inside your ears, which is pretty cool. You have an outer ear, a middle ear, and an inner ear, and they all work together. So, if one part of your ear is not working correctly, then you're going to have a hard time hearing because all three parts are needed to work correctly in order to be able to hear things the way that you need to. All right, so the outer ear catches the sound. So this is your outer ear, and it's going to catch the sound and pull it into your ear. The middle ear's job is to turn those into vibrations. So the middle ear is kind of like where you can kind of stick your finger at, but you don't really need to stick your fingers in there, so don't do it. That's your middle ear, and that's where your eardrum is found, and it catches those vibrations, turns that sound into a vibration, and helps you be able to hear. And then your inner ear. Let's see if I can get it to scroll down here. Your inner ear has the hammer, the anvil, and the stirrup. These are the tiniest bones that are found in your body, okay? And they pass the sound vibrations to the inner ear. Inside the inner ear, sorry, my email keeps going crazy. They pass the sound vibrations to the inner ear, and then inside the inner ear, you have the spiral-shaped cochlea. This is pronounced cochlea. It's filled with fluid, and it vibrates as the sound enters. When the liquid vibrates, it shakes the tiny hairs called cilia. So cilia is tiny hairs inside your ear that are inside the cochlea. Those hairs send the sound to your brain. That's pretty cool. Hair actually has a job in your ear. That's kind of gross. And they send the sound waves to your brain to the auditory nerve, okay? So moving on, now you know how the ear works. Here's an actual image of what your ear looks like. So this is from here to here is your outer ear. Your middle ear is basically where like your Q-tip would stop. You don't want your Q-tip to go in there because you could bust your eardrum, okay? And then your inner ear is way in here, and this is the cochlea, that spiral shaped, okay? And then the little hairs are inside this cochlea. And then this is the auditory nerve, that those little teeny tiny hairs carry that sound vibration to your brain. All right, let's look at the next. All right, so you need to understand pitch, frequency, and volume. Um, they all have a different purpose, okay? So how high or low a sound is called pitch, okay? So the higher the pitch, that's how high the sound is. The lower the pitch, that's how low the sound is, okay? So fast vibrations make those high pitched sounds. You guys have all, I'm sure, seen a video of like and a lady in the opera singing "Oh," really, really loud, and she makes these really, really fast vibrations with her mouth, and then she busts the glass. It's because those vibrations are moving so fast that the glass can't handle it and it busts it. The slower vibrations are going to be those lower sounds, okay? And you can do those like it says here by you can change the sounds by changing loosening and tightening a guitar string. If you pluck a tight string, it's going to have a higher pitch, and if you pluck a looser string, it's going to have a lower pitch. And it's because the tighter the string, the faster the vibration. The looser the string, the slower the vibration. All right, and now this is the talking about being further away from you. It says a change in wavelength can cause a change in pitch depending on how close or far away from something you are. So if you're really far away from something, even though it's a really high pitched sound, it's not going to sound as high pitched to you because the vibrations have had time to slow down in their waves. All right. Frequency is going to be the number of sound vibrations that happen in 1 second. So the frequency of sound waves determines its pitch. So the frequency is how fast or slow it's going. So the faster it goes, the higher the pitch. The slower it goes, the lower the pitch. The frequency determines what the pitch is going to be. The volume of the sound depends on the amount of energy that the waves are carrying. A sound with a lot of energy is loud, just like Lana, and a sound with lower energy is going to have a lower sound. Now, it says moving away from a source of sound can cause the sound to be softer. And remember, that comes into the frequency because the frequency of the wave is going to slow down. It may initially start off really, really fast, but by the time it reaches the wall, it may have slowed down by that time. And then it's going to bounce back and come back to your ears. So if you close yourself into a closet and you start yelling, it's going to be really loud in there. It's going to almost hurt your ears so loud because those vibrations are going to have a fast frequency and then they're going to be hitting those walls and then coming right back to your ear. Whereas if you yell outside and there's no walls to catch those vibrations, those sounds are not going to hurt your ears as badly because you're going to have slower frequency in those waves at some point because there's going to be nothing for it to bounce off and come back to your ear and hurt your ears. Let's see. All right. So that's going to be basically it. I'm going to go ahead and read this passage, this closed passage to you, just to put all of our information together in one tied up. This is going to be our bow to tie up our lesson here. Scientists define sound as a vibration or a wave that travels through the air. And once it has reached your ear, you can hear it. Like light, sound is energy and it travels in waves. All sounds are formed by some kind of movement. Sound can travel at different speeds. Since speed travels through objects, certain objects make it move faster. Sometimes objects can travel faster than the speed of sound. When this happens, it is called breaking the sound barrier. The sound travels at different speeds. Certain sounds are higher than others. How high or low a sound is called pitch. Fast vibrations make high pitched sounds, whereas slower vibrations make lower pitched sounds. Frequency is measured in the number of sound vibrations that happen in 1 second. The frequency of a sound wave determines its pitch. When you hear a pitch, it can be heard loudly or softly, depending on the frequency that it used. The volume of a sound depends on the amount of energy the sound wave carries. A sound with a lot of energy is loud. Softer sounds have less energy. As sound waves spread out through the air, they lose energy. This means that the closer you are to something, the louder it sounds. All right, guys, good luck.